Hello and welcome friends. In this session and also in the next session we'll be talking about the systems approach. Right? In this session I'll just talk about the systems approach in general, while in the next session we'll be basically discussing the systems approach in the context of management information system. Right? So let us understand what we mean by systems approach, and this is one particular approach that you might have read in business organization and management also. So basically systems approach, according to systems approach, what we mean by system, first of all, it is a set of interrelated components working together as integrated units to achieve common goals. So interrelated components are there and they are working together as integrated units to achieve some common goal. So this is what a system is, right? They've got interrelated. For example, I just give an example of the mobile phone. It also is a system. Why? Because it has got interrelated components. The screen is there, the processors are there, the storage is there. So all of them are working together, and when they work together as one integrated unit, then you get your mobile phone, and then only the mobile phone works. What if the processor stop working while all other components keep working smoothly? The mobile phone would not be able to work. Now this is what a system is, and the system is trying to achieve one common goal also. In this sense, it is providing you some functionality. So that is the common goal of all the systems, or all the systems. And if you talk about the mobile system, all the components of the mobile phones, the one goal that they are striving for is to provide you good mobile experience. Fine. So this is what a system is all about. We have got examples of natural systems and man-made systems. So this is one kind of categorization of systems, natural and man-made. As far as natural systems are concerned, which are present there already, solar system is there, and then man-made systems are, for example, education, banking. So this is one categorization of systems. So I hope you understand that what basically we mean by the systems. Let me underline some important aspects for you. The interrelated components, which means the components are related with each other, they are dependent on each other as well, and they work together. If they don't work together, it is not going to be of great use. They have to work together as one single integrated unit. Then only the system goal would be achieved. Is this fine? For example, the college in which you are studying is also a system. There are different components of that particular system. There are teachers, there is the clerical staff, there are the watchmen and the peons, and then there is the principal. Now if all of them don't work in a coordinated fashion, the college would fail, because the college would not be able to fulfill its common goal. And what is the common goal? To provide the students good education. This is the common goal. This is the common goal which is being shared by all the entities in the college. Now, if they don't work together as an integrated whole, they don't work together in a coordinated fashion, this common goal would not be achieved. What if the teacher is there to teach you in the class, but the peon is not there, and the classes, the locks are yet to be opened, the rooms are yet to be opened? Then can the class be held? No, it cannot be held. So all the components of the system have to work together in a coordinated fashion. Then only the system would work well and it would be able to achieve its desired objective. Right? Now see, this is a simple system model, and you can see here what is happening. Basically, input is getting converted to output and some processing is taking place. Now this is the simple system model. Basically what happens in a system, there is some input and then it is processed into an output. This is what a system does. If you talk about the college system, what does it do? The inputs are the students that we get, and we convert them into people with skills and knowledge and the ability to serve the society. Is this okay? So this is what the output would be, and then we are able to convert the inputs into outputs through this processing. So we are providing them classes, we are providing them career guidance, we are providing them value education. So this is all processing. So this is the simple system model. As I said, processing inputs into outputs, right? Let's talk a little bit about the system characteristics. What are the various characteristics of this system? See, a system will have some goal. It will be performing some task which will ultimately lead to realization of some goal. Now this is number one. There would be some objectives for which the system has been constituted, like I talked about the college. The cricket team that you have, right, or the dance troupe that you have is also system. And please understand, it cannot work if all the components, all the members of the group, they are not able to work in a coordinated fashion. It would not be able to achieve its desired objective of winning the dance competition, right? So, and the goal here in this case of a dance troupe is the objective of winning the competition. The goal is to win the competition. Second, there have to be some components in the system which would be called the modules or the subsystems. Now please understand, remember this particular term. The components of a system are known as subsystems. They are parts within the system, right? The modules of the system, they are known as subsystems. Now please understand that every system will have some components. If you talk about the dance troupe, the members of the group are the components, right? And they would be called subsystem. If the dance troupe is being called a system, they would be called subsystem. In case of solar system, the subsystem would be the Earth and the other planets, the moon and the other satellites, the meteors and the meteorites. So all these would be the subsystems. Then a system also has some structure, and there is a particular relationship between the different components. There's a relationship between different components. Fine. For example, if you talk about the college, and we have got different components, we have got the principal and we have got the faculty members, and there's a particular relationship between the two. Likewise, there's a particular relationship between the teacher and the peon. The principal is at the top of the hierarchy. The teachers are one notch below the principal, and the teachers are reporting to the principal while the principal is the boss. Now this is the relationship between the two. So all the systems have this characteristic also. In a particular system, the different components which are there, they have some relationship among themselves, right? And then system behavior. The system reacts to the environment also. The system will certainly react to the environment. For example, because of the COVID-19 lockdown, we had to close down the college. Now this was our reaction to the development in the environment. Now what if a private college opens up, is set up somewhere here in Pithoragarh? What will happen? Don't you think in this case we also will be reacting to this environment? We'll have a competition now, and don't you think we'll try to improve our efficiency, we'll try to improve our processes, we'll try to provide even more quality education to our students, even better quality education to our students, because now we are reacting to the environment, reacting to the growing competition in the environment. So the system would react to the changes in the environment. Now take example of the dance troupe that you have, the dance group, and suppose you come to know that the break dance is now no more in vogue, and the in thing, the trendy thing is the Kumaoni dance. Don't you think you would react to this change in the environment, and you would also want to practice Kumaoni dance? You understand? So the system would react to the environment. And systems also have a proper control procedure. Now have a look at the control procedure, which ensures that the system is working as per plan. So the systems should ideally have a control procedure. They should ideally have some control, so that they ensure that the system is working exactly as per plan, right? Fine. So control is also a necessary characteristic of a system. So in case of our college, suppose the teacher does not come to teach in the class, what will happen? This will ultimately impact the shared objective of the various components of the college, various entities in the college, and it would impact the whole college. Now, do we have a control mechanism for this? Yes, we have. The principal can come and inspect whether the teacher is there in the class or not. So this is the control mechanism that we are talking about. In the dance troupe that you have, what is, you are simply not able to dance in a very coordinated fashion. It is not coming out beautifully. Do you have a control mechanism? Yes, you do have control mechanisms. You might do what? You might assign different roles to different members. You might switch their roles. So the one who is not performing well will be pulled out from the front row, and it will be, that particular person will be shifted to the last row, while the ones who are performing well, they would probably be now shifted to the front row. So you understand this point. So the control should also be there in a system, and it is always there in the system. And then the system has its own life, and it goes through various stages in its life cycle, right? For example, the various stages have been there can be various stages, and we'll be having a look at the various stages in the ensuing discussions. However, right now you need to understand that the system will have different phases in its life cycle. It would have a beginning, and then it would have a growth trajectory, and then there would be a decline at some point of time. So these stages are known as the phases of the life cycle of the system, right? Fine. So a system will have its phases also. In case of your dance troupe, the group was formed, and then they started practicing, they performed in the competition, they won the competition, and then the group was dissolved. Now this was basically the life cycle of your dance group as a system, and there were different stages. First it was formed, and then it started performing, and then won the competition, and then it was dissolved. So these are the various stages in the life cycle of that particular dance troupe, right? So these are the various characteristics of a system. Now let's have a look at the system approach. Now what do we mean by systems approach? Up till now we've been talking about the system, what happens in a system, what are the characteristics of a system, but then what is system approach? This is what we are going to take up now. System is made up of parts. So we are borrowing this philosophy, the system approach or the system philosophy, from our discussion on systems. We have just had this discussion. Now basically the system approach actually borrows from that discussion only. So system would be made up of parts, subsystems. Now please understand and remember this term. I have told you earlier also that you need to remember this particular term. The parts or the components of the systems are known as the subsystems, right? This is number one. The whole is primary and the parts are secondary. Now what is more important, whether the system is important or the subsystem is important? The whole is primary, the system is important, the subsystem exists so that the system can perform its function. So the subsystems are not important. What is important is the system, the whole, while the parts are not very important. You understand this point? Even your body is a system. You have got different organs which can be called subsystems. Is hand important in itself? No, it's not important. It is important as part of the body. Otherwise it's not important. Please understand. Which means that the parts are not important, that the whole is more important than the parts. Subsystems are interrelated. The subsystems would be interrelated, and I have discussed this point earlier also, right? So then you have got a hand and you have got a heart also. If the hand would work well only if the heart is supplying blood to hands in a proper manner. If the heart somehow fails to supply blood to your hand, what will happen? there might be problems. You might face a paralysis. Is this okay? Or there could be other problems and the hand would not be able to work well. So these subsystems are interrelated. They've got some relation among them. So hand and heart, they are connected. Kidney and skin, they are connected, right? Is this understood? So, and I'm talking of the body as a system now. I've changed the example, right? Now system works smoothly only if all the system works properly. Can you think of, do you know some very healthy person who is having a problem in his heart or whose kidneys are not functioning properly? No, you would not have come across this kind of a person, which means that the system is only going to work well if the subsystems work properly. Look at the mobile phone that you have. What if the processors fail to run? Would the mobile phone still be as useful to you as it was earlier? No, it would not be useful. It would lose all its use because it would simply not be able to function without a processor. So the system works only smoothly only if the subsystems are working properly. And subsystems have value only as part of the larger system. Hand all alone in your body is not going to be of great use until unless it's part of the larger system. Until unless it is part of the whole body, it is of no use, right? There are people who are bald. They are ganje. For them, if they find some hair lying somewhere, is it going to be of any use to them? No. The hair have their importance only if they are a part of the body. Then only they are having their importance. So the subsystems have value only as part of the larger system. What is the use of a processor to you if it is not there in the mobile system? If it is kept just like that, it is of no use to you. So subsystems have value only as part of the larger system, right? Now let us talk about the different types of systems that we have. What are the different types of systems that we have? Number one, and we are basically going to talk about different types of categorization. You might be reading about even more types of categorization. I have taken up only 4 or 5 of them. So you might want to supplement this knowledge with your book readings also, wherein you might come across other types also, other categorizations also. Now in this particular slide, I'll only be talking about 4 or 5 of them, right? So let's talk about the different types of systems that we have, and let's talk about different types of categorization. So one categorization and one distinction could be open system versus the closed system. Open system is one which interacts with environment, right? So it will interact with environment. For example, plants and animals, don't they interact with the environment? Plants, you know about transpiration, you know about how they extract nutrients from the soil for their growth and how they produce oxygen. So in a way they are interacting with the environment, which means they are getting impacted by the environment, and in turn they are also impacting the environment. So there's a two-way interaction, plants and animals. Closed system, generally there would be no interaction in any direction. Nor the system would interact with the environment, nor system would do anything, would make any impact on the environment, nor the impact would be able to impact the system. And this happens only rarely. It is just not possible in nature. You can call a thermoflask, a thermos that you have, it can be taken as an example of a closed system, an insulated container. Why? Because once you have kept the hot tea in that particular insulated container, that thermoflask, what will happen? It will not lose any heat, and that is why it will not lose any heat to the environment, and that is why the tea will remain hot even 3 years, even after 3 hours or 4 hours, right? So you can consider that kind of a container a close approximation of a closed system, but even that is not a perfectly closed system. Why? Because if you keep that tea in that particular container, a hot tea, some hot tea in that container, yes, it would retain its temperature in 3 or 4 hours. That is perfectly fine for the next 3 or 4 hours. But would it be able to retain its temperature for the next 5 weeks, 5 months, 5 years? No, it would not be able to, because actually it is losing some heat energy to the environment, though at a very, very slow rate, but it is still losing some heat energy to the environment. So in that sense, it is impacting the environment. It is actually losing its heat energy into the environment, and it is basically heating up the environment in that sense. So closed systems are generally very, very, they are not found practically in nature, right? Then we have got the super system and the subsystem, and I have discussed the subsystem. Now, should I start with the subsystem first? Now, what happens in a subsystem? Subsystem is part of a system. I talked about the hand that you have, the intestines that you have, the lungs that you have. They are basically the subsystems of the body, which is the system here. So the parts of a system are known as subsystem, and we have taken example of HRM division is a subsystem of a company known as TCS. So Tata Consultancy Service would have their own HRM division, Human Resource Management division, and HRM would be the subsystem of the system, which is TCS. On the other hand, what is a super system? Have a look at the super system now. Higher level formed by systems coming together. So it is the next higher level, and that is why it is called the super system, right? So subsystem is the level one notch below the system, while the super system is one notch above the system. So higher level formed by systems coming together. Now this is the super system. If you talk about Tata Group, it is the super system of TCS. I hope you know that TCS is a firm. It's a Tata Group firm, and Tata Group has got so many different firms, including Tata Motors. You have got Tata Chemicals. You have got the Tata Consultancy Service, and then there are so many firms, Tata Tetley, the Taj group of hotels that the Tata have. So all these are basically their members of the Tata group. Now if you talk about the Tata group, it would be a super system of TCS. So TCS is a group company, so Tata group is the super system, and within TCS, HRM is a subsystem of TCS, right? However, we can put it conversely in a different manner also. Tata group is a super system of TCS. We can also say that TCS is a subsystem of Tata group. If now here we are considering Tata group as a system, then TCS would be one notch below Tata group, and that is why we'll call it the subsystem of Tata group. Likewise, we can also say, we have said that HRM division is the subsystem of TCS, because HRM division is within the TCS, it's one notch below TCS. We can always say that TCS is the super system of HRM division. So please remember this, these terminologies: system, subsystem and super system. Now let us talk about the deterministic system and the probabilistic system. Now deterministic is where you can determine something with 100% accuracy, and that has been mentioned here. Occurrence of events is certain, perfectly predictable. For example, the paper pattern, not the question paper, not the questions in the question paper, we are talking about the pattern. So occurrence of events is certain, you can predict with 100% accuracy a particular event, then it becomes basically deterministic system. So in those systems where you can predict the outcomes with 100% accuracy, they are called deterministic system. For example, exam paper format. You know that the format will have, let's say, these many 5 short answer questions will be there, and 3 long answer type questions would be there. So this makes it a total of 70. Now you know this format, and this has been circulated by the university. Now you know that the exam paper pattern would be exactly in this particular format. Now this is a deterministic system. On the other hand, there are probabilistic system where you cannot determine the outcome. You simply cannot predict with 100% accuracy. Your predictions may always go wrong. There is a chance, there is a possibility that your predictions might go wrong, and that is why these kind of systems are known as probabilistic system. The sales forecast system, for example. Can you predict the sales with 100% accuracy? You would certainly not be able to do that. Think of what various automobile firms had done here in India in the year 2019-20. They had predicted a growth in the car sales. However, what happened? There was lockdown in the month of March, because of which their sales suffered and the expected growth in sales could not be materialized. On the other hand, if you talk about telecom companies, they were not expecting this kind of growth, but because of the lockdown, people had to stay in their homes, and because of which their mobile usage increased, and the average revenue per user, how much revenue they are earning from one single user on an average, this increased for the various telecom firms during the lockdown. So you simply cannot predict how much you are going to be able to sell and what would be the sales volume and what would be the sales revenue, and that is why this would be known as a probabilistic system, right? Then we have got the temporary system and the permanent system. You understand, temporary would be having shorter lifespans, and they are basically meant for particular group. I talked about the dance troupe that you have formed, dance group that you have formed so that you can participate in the competition and win prizes there. That would be a temporary system. A virus is a temporary system. It is there only for a short period of time. A virus can reproduce in the sense that it can cause more number of viruses, but one single virus will have a limited short time period, short lifespan. So that is what a temporary system is. Even human body is a temporary system. You cannot survive for millions of years. You would only be able to survive for a few years. Permanent systems have longer life. They are almost permanent. For example, solar system. Solar system is not going to burn itself up in 100 years or 200 years. It has existed since million of years, and it will exist for the coming million of years. So the solar system can be taken as an example of a permanent system. However, just like was the case with the closed system, please understand that there is ideally no permanent system. Even it is expected that the life of sun, probably, I'm not very sure, we'll have to cross check the facts. The life of the sun is 8 billion years, and out of which we've already had 4 billion years. So in another 4 billion years, the sun would have spent all its fuel, and then the whole solar system would collapse. So ideally no permanent system actually exists. The most permanent of the system would also would also shut down in another 4 billion years, right? And then let's talk about the last categorization, wherein we'll be talking about the physical systems and the abstract system. Physicals are the ones which you can see and touch. They are tangible, right? For example, the chair that you have is a system. And what are the subsystems? Can you talk about the subsystems? What are the subsystems in the chair that you have? The armrest, the footrest, the backrest, they are all the subsystems of the chair. And what is the supersystem? What is the supersystem? The furniture is the supersystem of which this chair is a part, and chair is the system, so the furniture becomes the supersystem. However, they are physical systems because you can see them, touch it, tangible in nature, and they can be static or dynamic. Static means they would be stationary, and dynamic is when they keep on changing. So these kind of physical systems can be further categorized into static or dynamic. On the other hand, we've got abstract systems. Abstracts are the systems which don't exist in reality. They cannot be seen as such. They cannot be touched as such. For example, idea about God. I'm not talking about God as such. I'm talking about the idea about God. Now, idea about God is part of your thought process. It is not something that you can see. If it is not something that you can touch, so they are abstract in that sense, right? So the conceptual or the non-physical systems, they are abstract systems, right? Because you simply cannot see them, you simply cannot touch them. Yes, you can feel their presence, but you simply cannot see or touch them. So idea about God, for example, is an abstract system, right? So these were the different categorizations of systems. Now that we have completed these categorizations, now we are going to move over to the system approach in MIS, how we actually apply the system approach in MIS, and what are the various subcomponents of the MIS, Management Information System. This is going to be the agenda in the next session. Thank you very much.